Okay, so in this problem I'm playing pool and I shoot a 0.5 kilogram cue ball into a 0.3 kilogram other pool ball to try to make it go in this hole right here. Now, what we know is the mass of the two balls, and we also know that the original speed that the first cue ball is going is 3 meters per second, and then the cue ball bounces off with a speed of 2 meters per second at an angle of 30 degrees from the horizontal. Now what we're looking for in this problem is the final velocity of this second ball that's hit. Now we go ahead and we know that the first momentum is going to be this P1. We know that there's also a second and a third momentum, which is the ball of the cue ball going this way, which is P2, and the ball of the second ball, or excuse me, the momentum of the second ball, which is P3, going this way. So we know that momentum is conserved in this problem, and we know that P equals the momentum equals the mass times the velocity. Now, let's go ahead and just break this P1 into its components. We know that P1x equals the mass, which is 0.5 kilograms, times the velocity, which is 3 meters per second, and we get 1.3 kilogram meter per second x hat. Now let's go ahead. We know that there's no y component to this force, or to this this ball. We know that it's not moving the y direction, so we know that P1y is going to equal 0. Now let's look at P2. We know that P2 is going this direction, so we know that it has an x and a y component, so let's break it down into those components. We know that P2x equals the mass, 0.5 kilograms, times 2 times the cosine, which will give us this side, the cosine of 30 degrees, and we get 0.87 kilogram meters per second x hat. And same thing for the y, we get 0.5 kilograms times 2 times the sine of 30, and we get 0.5 kilogram meters per second y hat. Now we know because momentum is conserved in this problem, we know that P1, which is this original momentum, will equal P2 plus P3. So we know the sum of the momentums will equal the original momentum. So let's go ahead and just break this into components. So we know P1x is going to equal P2x plus P3x. So we know that P1x is 1.3 kilograms meters per second. We found it right here. Equals P2x, which we found is 0.87 kilogram meters per second, plus P3x, which is what we're looking for. We solve for P3x and we end up with 0.43 kilogram meters per second. Now we're not looking for the momentum, we're looking for the velocity. And we know that we have found the x momentum, so to find the x velocity in the x direction, we know that momentum of the x will equal the mass times the velocity of the x. So we just solve for this velocity and we end up with P3x over m. We just plug the numbers in that we found, 0.43 kilogram meters per second over the mass of the second ball, because we're trying to look for the speed the second ball is going, which is 0.3 kilograms, and we end up with a velocity of 1.43 meters per second x hat. Now we're just going to go ahead and do the same exact thing for the y velocity. We know that the momentum of 1y equals the momentum of 2y plus the momentum of the 3y. So we plug in our numbers. We know that P1y, there's no we know that there's no component in the y direction, so it's just going to be 0, equals 0.5, which we have P2y, plus the P3y, which is what we're looking for. And we just solve this and we end up with negative 0.5 kilogram meters per second for the momentum in the y direction. Now we can go ahead and just solve this for velocity. We know that Py equals the mass times the velocity of the y. So we just plug in P3y, which is negative 0.05 kilograms meters per second, equals the mass, which is 0.3 of this second ball right here, times the velocity, and we end up with a velocity of negative 1.3 meters per second. So we know this second ball is traveling at a velocity of, actually there's no, pardon me, there's no, because it's a component, a velocity of 1.43 meters per second in the x direction minus 1.73 meters per second in the y direction.